Alright guys, let's go. Okay, right now let's look at group 2 element. So group 2 element, right, we have another name given to them. We call it as alkaline earth metal, yeah. Okay. So guys, for alkaline earth metal, what we have? So they have 2 electrons occupy an S subshell, yeah. So for example, we have 1s2, 2s2, 3s2, dot dot dot. Nadia, what happened, Nadia? 3p64s2, dot 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 5s2, dot 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 6s2. So it's always S2, S2, S2. All right, guys, now please tell me, atomic radius as it goes down, increases or decreases? Atomic radius as it goes down, increases down the group, right? Why? What's the reason, guys? Shielding effect increases. Charge density. Oh, yo. Good job. Guys, remember that, yeah? All right, guys. Melting point of the element as it goes down decreases down the group, yeah? Okay, but there is an exception, which is magnesium and calcium. So you see, right, guys, this magnesium and calcium, right, will form an exception, yeah, for okay, an exception on magnesium and calcium, okay, on the atomic radius and also on the melting point and also the density. All right, guys, why melting point decreases down the group? What's the reason, guys? When we talk about melting point, we always have to talk about what? Wait, what? This metabol, this group 2, mana ada INF, my friend.
Oh, yeah.
Yes, what it is? Please tell me. I'm not telling you guys, you guys tell me, yeah. This is a recap, yeah. Go. Number of electrons, almost. So guys, again, when you see the word melting point, you must relate to bonding. What type of bonding it is? Metallic bonding, right? So you hit it right on. So metallic bonding, you have to talk about the strength of metallic bonding. So as you go down, the delocalized electron is further and further away from the nucleus. Attraction between the positively charged ion and the delocalized electron is weaker. Get me? So atomic radius increases and you have a weaker attraction. Get me? Yes, sir. All right, guys, what about density? As it goes down, increase or decrease? All right, guys. Physics, what's density?
Mass over volume.
Mass over volume, which means how heavy it is. As it goes down, atomic mass increases. So density?
But I thought it has more volume.
It has more volume, but it gets way heavier.
So increase.
Yes, correct. Highlight the word ionization energy decreases down the group. Highlight reducing power increases down the group. All right, boys, girls. Second question. Q1. I ask my boy, Joe boy. Answer. Chop. So chop. Give answer.
I going down to 2
Why?
Yeah.
Bro, I just said I just told you the answer. Playful now. Text your boyfriend some more.
metallic bond.
Metallic boy what? Stronger or weaker? Okay, first point, weaker metallic bonding. But guys, why? Because as it goes down, what happened to the atomic radius? Shooting effect. Well done. What else? So I can mention the delocalized electron is further or closer. So your delocalized electrons are further away from your nucleus, right? Which result in weaker nuclear attraction. Get me? That's it. Clear, good boy. Alright, guys. The next question, I'm not telling you the answer. I want you guys to think about it. Go and tell me the answer later on. Don't just guess, please. Don't just hit. You think this is not a lottery. Don't randomly just guess. You have to come up with the reasoning first. Come up with the reasoning first. Okay, I'll show you group 2. And you guys tell me the answer.
The last one.
The last one. Right, someone said the last one.
The 88.
The 88.
Radium.
Radium. Why?
Reducing power increases down the group.
Why?
Because its electron is further away from the nucleus, right?
Okay.
So it's like lost more easily.
Okay, yeah, continue. Yes, go on.
Continue.
Yeah. Then when electron is lost, they undergo oxidation.
Oxidation.
Yes. Perfect answer right there.
Oh.
Whoa. Alright, guys, you see, okay, I know, okay, this is the difference between, let me tell you this, you have to fix your thinking process, especially when you're doing it exam. So, you see, right, some kids, if this is you, some kids, right, who never read the question will just jump into conclusion. So, some kids will just choose BE. Or, for example, some kids will just choose RA. Okay, then after that, you have to tell me, oh, why? Because it's the last element, easiest factors, correct? Then after that is the easiest to donate electron, correct? Then which means undergo oxidation. Okay, then best reducing power. Okay, yes, this is a correct answer, but your thought process shouldn't be like that. Okay, so a good thought process to not trick by the exam, right, is always to elaborate from here. So your thought process, the actual one, right, should be reducing power agent is the one that undergo oxidation. Get me? Is the one that undergo oxidation is the one that donates electron the easiest. Is the one that is having the fattest or the biggest atomic radius, and the answer is RA. I mean, your thought process should be reverse one, understand? So again, guys, do not jump into conclusion. Okay, this they call it as a framing mindset. If you frame the answer, you just write whatsoever nonsense to match your answer. Okay, so some kid will just 50%, beryllium, then just randomly write. No, you shouldn't do that. Okay, you should always ask yourself why. Why? Always why first, instead of what. You don't what first, If you what first, then your answer all most likely gonna be not hitting the right spot. Okay, so ask yourself why. What is why strongest reducing agent? Okay, come. So guys, the answer is well done. RA is your answer. Okay. Why is it so? Largest atomic radius, correct. Which means it's having the most shielding. Get me? Okay, at the same time, this RA, right, is also having the lowest charge density. Is that right? Correct, right? Which means it's having the weakest nuclear charge. It's right, weakest nuclear attraction. Alright, guys, let me ask you a question, guys. What is the process given for an atom to donate electrons, to turn into positive charge? Think about it. You've done it before in chapter 2. What is the name of the process that is given to get to a gaseous atom to give out electrons to turn into positive Ion. Ionization energy. Get me? So you have to talk about ionization energy. Basically, Ra is having lowest ionization energy. Get me? Which means it's the easiest to lose electron. Am I right? Which means it's the easiest to be oxidized. Can I, guys? Okay, try to frame your answer. Try to practice writing your answer like how I write it. Yeah, you see, my answer is straight to the point. No nonsense. No and or if what. Therefore, this is because. Now, nonsense. Straight to the point. Okay. Hi guys, let's go. Reaction of group 2 elements. Always remember, they always form a +2 oxidation state. Usually form ionic. Usually, yeah. Okay. And metal are reducing agent because they undergo oxidation. Guys, reactivity going down. Increases. Why? Tell me the reason why.
Atomic radius increases down the group.
Okay.
There is greater shielding by inner shell.
Yo.
And less energy is needed.
Well done. Lower ionization energy. Well, not bad, huh? Not knocking in, huh? Alright, guys. That's it, yeah. Alright, come. Let's look at the second one we have. Flame test. Magnesium. Flame test, what color? White. I'm going to write with white color. White. Flame. Okay, I wrote something. Wow. Calcium is white flame. Magnesium is white flame. Second one, calcium is brick red. Okay, or you see orange red. Strontium is scarlet red.
Can we do that?
Barium is apple green. Do what?
Scarlet red.
Oh yeah, you just put red Kennedy. I'm just being extra. Testing my English. Okay. Alright guys, next. Reactivity increases, yeah. Well done. Alright guys, let's go. Next question. Oi, Chaji, do See, I teach you chemistry, you teach me all the weird things. Even my Korean friend also never teach me that.
Wait, you know Huang Yesong, right?
Yeah,
Is he smart?
I think Yesu is kind of smart. Is he smart? He's looking right. I thought he's your friend.
Yeah, but I don't see him often.
Why? You make friend with the smart people, ma.
Big friends, bro. Know me every
You
day.
say my English not good. I never say your English not good. I say your English very good. I never say so. English okay ba? You want English teacher or not? I recommend you Joe Boy. You follow his IG. He teach you English.
Wow.
This boy, really. Alright, guys, let's go. Element. Oh, wait. The first question I haven't teach you yet. Don't do. Alright, guys, next. Most volatile element in a group that contains element of 3 states of matter at room temperature and pressure. Guys, what is volatility means? Most volatile means the easiest to evaporate. So, guys, there's only one group, right, that consists elements of 3 different states of matter. Group 7. What? Gas, liquid, solid. Oh, bromine. Then iodine is solid. So the answer is F. Alright, guys, last one. Give me the correct answer. Come. Which one is the answer? CS, BA, LIMG, ATNE. Which one? Forms the largest cation ion.
What is CS?
Feel like CS. CS or BA?
Wait, no, VA.
No? No U-turn yet. CS.
Wait, cation, right? So
Yes.
CS.
CS or BA? So guys, what CS and BA forms? CS plus, BA, 2 plus. So guys, let's look at the last period. CS, BA, 55 proton, 56. What about electrons? 54, 54. So one more time, which one is larger? Thank you very much. Your answer is yes. Okay, alright guys, next. Page 4 now. Alright guys, part B, let's look at the reaction with water. So group 2 metal reacts with water to form metal hydroxide and hydrogen gas. Okay. So guys, notice that this is a redox reaction, yeah. Why? Because magnesium has been oxidized from 0 to 2 plus, right? H2 has been reduced from +1 to 0. Thank you very much. Smart. Right. So 0 to +2 undergo oxidation, +1 to 0 undergo reduction, right? Guys, if I throw group 2 elements into water, going down the group, what happens to the reactivity? More vigorous, well done. Increases down the group. Okay. Okay, guys, I have a question. Why dissolving group 1 oxide produces higher pH? What's the reason?
The hydroxide ions.
Ah, yes. Well done. Oh my God. Not bad, not bad. All right, good job, guys. The reason why, because group 1 oxide dissolve completely. I remember that, yeah. When they dissolve completely or dissolve fully. Forming group 1 hydroxide. And guys, for group 1 hydroxide form, right? Remember, a group 1 hydroxide is more soluble, very soluble, in fact. In fact, it's 100% soluble. So which means the concentration of OH minus produced is higher, right? Which means, guys, the higher the concentration of OH minus, what happens to the pH? Increase up. Okay, please write it down. Good. Alright, guys, next. Group 2 metal reacts with what acid to form? What it forms? Salt and hydrogen gas. Alright, guys, I give you multiple equation. I want you guys to balance it. Go. Alongside with state symbol, guys. Let's go, kid. Equation. Alright, guys, let's go. Mg plus HCl. MgCl2 equals, yeah, H2 gas, 2HCl. Next one. Ca bracket NO32 equals H2. Balance 2HNO3. Alright, guys, next one. BaSO4. State symbol. Thank you very much. Yo boy. Alright, BaSO4 plus H2. So guys, remember that, yeah, barium sulfate, it's a solid. Color of barium sulfate, guys. Yes, what PPT? Guys, this is the most popular PPT, yeah, please. Yeah. Precipitate. Alright, guys, next. Reactivity of group 2 metal increases going down, yeah. Alright, guys, remember this, yeah. If I take a group 2 metal such as barium or strontium with sulfuric acid, right? It will hardly go to completion, yeah. It will never go to completion, in fact. Okay, I'll explain it later. Okay, guys, any group 2 chloride are always soluble, yeah. Okay, always soluble, which means it's always an AQ and it's a colorless solution. Okay? Easier. Good. Okay, guys, next question. Please tell me the answer. 3 marks. I need 3 marks. Next page. Oh, you know all my 10B kids then? You know all my 10B kids? Have many. Wait, who's popular in your year? I know. Guys, no, macam no popular guys in your year like that. A girl's got Eva. Eva Chong, is it Eva Chong? I don't know. The Chinese girl, like a tiny one. Who else, my student? Oh, you know Eva Alexis also. Oh, Eva Chong Wen-chi. Yeah. Oh, no, another Eva. There's another Eva. Oh, from 10B. Alright, guys, let's go next question. What's wrong with you guys, bro? Alright, guys, calcium and radium are both from group 2. Why the reaction of calcium and Ra happens at different rate? Why? What's the reason?
Different reactivity.
Yeah, why? Yeah, okay. Good, different reactivity. Why?
The atomic radius.
Now, atomic radius increases, shielding effect increases. So
it's more reactive.
okay, yo. Well done. Good job. Alright, so guys, well done. I can say that, right? Radium reacts more vigorously with HCl. Why? Because you have a greater atomic radius. Right. You also have a greater shielding effect. What else? You have a lower charge density. Weaker nuclear attraction. Oh my god. I'm just keep spamming points, bro. So Ra has lower ionization energy. Easier to lose electron. Okay. Joe boy, start to follow you. Alright guys, next. Reaction of oxides with water. Metal oxide react with water to form metal hydroxide. Example, strontium oxide reacts with water, strontium hydroxide. Okay guys, next. You see, right? Similar, the resulting solution has a high pH. Why? Because you have OH minuses formed. Okay. So guys, for calcium hydroxide, it's a weak base. Guys, what's the definition of weak base again? Dissociate partially in water to form OH minus solution, right? So guys, do you know how to write the equation? CaOH2 solid. If I try to dissolve it, what will be? Reversible reaction now, yeah. Ca2 plus AQ 2OH minus AQ. Get me? Alright guys, my next question is, what happens to the concentration of OH minus? Low or high? Concentration of OH minus is low, which means it's going to form a weak base. Correct. pH of a weak base, guys. Yeah. 9 what? Okay, so yes, pH of a weak base 911. Okay. Alright guys, next. General reaction and dissolving group 2 metal oxide and water. So if I take a group 2 oxide, XO, if I throw in water, what it's going to form? Metal hydroxide. Okay, and if you dissolve it, this is a dissolving equation. X2 plus and 2OH minus. That's it. Okay, we are almost done already. 70%. Next week, we'll move on to halogen, chapter 11, which is hard chapter again. And guys, however, since the reactivity increases down the group, the reaction of oxide varies down the group. Guys, I have a question. If I take this 4 oxide, throw into water, which one will give the highest pH? Tell me, which one will get you the highest pH? I want highest pH. Yeah, let's go. How? That's a good question. You have to tell me the answer. Or else you stay here with me. Ha. Can I go back? Go boy! Let's go. What's your answer? Hmm. Anyone online kid? Alex. Alex, I found you your high school mate. Thank you, Felice. What? I found you your high school mate. Joe, what's your full name? Joe boy, yes, correct. Joe boy. Bro, she legit say Joe boy. Joe boy, yes, correct. Joe boy. Yeah, correct. Joe guy, what Joe guy lah, Joe boy lah, bro. What guy, bro? You know, not a guy, bro. Boy. Yes, Joe boy. Hey, answer. How? Waiting. Bro. Bro. Stupid. BAO is your correct answer. What the heck? Ew. Bro, my childhood tomato exploded, bro. What the hell? That's disgusting, man. Damn disgusting. Yes, BAO. Ew. So guys, yes, the answer is BAO. What's the reason? Alright, guys, this is the strongest base. One reason, please tell me, as it goes down, what happened to the reactivity with H2O? Increases, right? Correct. Which means the concentration of OH minus increases as well. Which means your pH is gonna go up as well. That's it. Okay, cool. Strontium and barium hydroxide. This is gonna be a colorless solution. Get me? No color one, yeah. All right, next. All right, guys, now let's look at it. I want you guys to write it down. So as you go down, right, my solubility of hydroxide, your group 2 hydroxide always increases. Which means the concentration of your OH minus increases. Well done. Which means the pH gonna be, yes, well done. Your pH going down, it's higher. Yeah. Can I check my WhatsApp later? I have full day class. I haven't checked my WhatsApp yet. I think you sent me a past paper, right, that you want me to go through it. All right, guys, now let's look at the pH here. So the pH here, right, is about 9 to 10, yeah. Okay, so going down, your strontium is a strong base, high pH strong base. And is Nadia, right? All right, guys, next. As solubility increases going down the group, the pH of the solution form increases, yeah. Highlight the word pH of the solution increases. Why? Because the concentration of OH minus produced increases. Well done. Now guys, this entire picture, please put some stars here. This is very popular. Almost 100% of coming out in the exam. 100% coming out, be it in your P1 or P2, but it's 100% coming out. 100. Sorry? They will ask you to compare solubility of hydroxide. What kind of question? Later you'll see MCQ, mostly MCQ. Okay, right now let's look at sulfate. So solubility of sulfate always decreases going down the road. So guys, magnesium sulfate is the most soluble. This is slightly soluble already. These two are insoluble already. This is always aqueous. This could be aqueous or solid, but bottom is always solid. Color of sulfate precipitate is also a white PPT. Understand? What about the solution here? Color? That's the color. Colorless solution. Okay. Alright guys, next. Let's look at it. For solubility of sulfate, I want you guys to write down solubility of sulfate decreases going down. Okay, solubility of sulfate decreases going down. That's it. Okay, done. Okay, guys, once done, page 8. Alright, guys, that's page 8. Question asked me. Okay, what we have, right, is the reaction of carbonate with water and acid. Alright, guys, if you look at carbonate, is carbonate soluble? Group 1 carbonate is soluble, but other carbonate are never soluble. Remember, carbonate are never soluble except for group 1. Alright, guys, write down. All carbonates are insoluble. Remember that. Except for a group 1 carbonate or ammonium carbonate. That's it. Okay. Alright, guys, let's go. So first one, let's say if I take a group 2 carbonate, if I throw into water, will they react or will they dissolve? No, there's no reaction. So group 2 carbonate, remember that they do not dissolve, are insoluble in water. But guys, let's say if you throw it into acid, right? Yes, they will have a reaction. Okay, so you will get a salt, water, and carbon dioxide. Clear? Alright, guys, next. I want you guys to complete these 3 equations. Go, go, go. My turn to go washroom. Let's go. Let's go. First one, MgCO3 plus HCl plus CO. MgCl2 stay simple. Aqueous plus H2O, CO2, right? Well done. Okay, first question correct. Balance the equation by putting a 2. Second one, Ca bracket NO32 aqueous plus H2O plus CO2, yeah. Balance equation, putting a 2. Next. Stay simple? Wrong. Solid. Remember, barium sulfate is never aqueous. Don't get tricked. BaSO4 is a solid always. It's insoluble. Okay? Plus H2O plus CO2. Double underline or highlight the state symbol for barium sulfate. Clear? Guys, we'll be done with chapters 10 by today. After this, we are moving on to chapter 11. Halogens. Also very important chapter. Organic already, right? I don't know why some of the school teacher skip. Yeah. All this chapter is very important. I mean, organic is also very important, but this chapter are very important, always come in your P2. Okay, so guys, all this in organic, you cannot skip at all. How guys, next. So you see, reaction of with acid, right? With calcium, strontium, and Ba, right? Highlight the word CaSaBa with sulfuric acid stop after a while. Highlight the word due to the formation of an insoluble sulfate layer form. Alright guys, to help you properly visualize the entire reaction, you see, right? Let's say if I have some barium carbonate, okay, I have some BaCO3 solid, yeah. Then guys, I'm gonna add some H2SO4 inside. If I add some H2SO4 inside, what's gonna be? Okay, so I'm gonna take this, throw a H2SO4 inside. Okay, so, but the reaction, right, stop after a while, yeah. Why? What's the reason? Guys, what's the equation again? BaCO3 plus H2SO4 turn into BaSO4, right? Guys, what is BaSO4 again? It's an insoluble sulfate layer. Get me? So this insoluble sulfate layer, right, is gonna, okay, it's gonna cover up the reactant. When it's formed, it's gonna cover up the reactant. Get me? So this is your insoluble sulfate layer. Okay, so when this is formed, right, it covers up the reactant. Right now, right, your carbonate and H2SO4 molecule are no longer reacting. Get me or not? So they are no longer touching each other. So the reaction stop. Okay, Alright guys, let's go. Alright, first guys, I have an insoluble BaSO4 layer from side. Then it cover the reactant, yeah. Alright, then eventually, okay, BaCO3 is no longer in a chemical contact with a H2SO4 molecule, understand? So now, right now, right, they are no longer touching here, which means there's no reaction. And then your reaction stop. Done? Once done, next page. I want you guys to look at page 10 now. Alright, this is the last part. Then we are done with chapter 10. And we'll move on to group 7, chapter 11. So we are one chapter away from organic chem. I might assign chapter 12 as homework. So what I'm going to do, right, I might post my recording on YouTube. I will assign the notes. Then I'll just ask you guys to refer to a recording and do. Because chapter 13, right, sorry, chapter 12, nitrogen is nonsense. Like, it's very easy chapter. So we save some time, we focus more on organic. I can spend more time on inorganic. Alright guys, next, we have thermal decomposition of carbonates. Alright guys, let's look at thermal decomposition of carbonates. Oh my god, this thermal decomposition reaction, right? Chances of coming out 80%. 80% coming out. I'm talking about your final AS exam, not your school exam. I do not know what will come out in your school exam. But AS chemistry, I'm pretty sure 80% you will get this question. Either in MCQ or in paper 2, mostly in MCQ. Thermal decomposition refer to a reaction, okay, by breaking down compound using heat. So thermal stability is how resistant the substance is, right, towards heat. Yeah. So when heated, always remember carbonate decompose to form metal oxide and carbon dioxide. Alright guys, next. Temperature at which thermal decomposition. Okay, I want you guys to look at this table first. So looking at this table, magnesium carbonate, yeah, is the least stable. Okay, it's the least thermally stable. Barium carbonate, on the other hand, is the most thermally stable. That's it. Alright, these two, I want you guys to write it down. So guys, as it goes down, it has higher thermal stability. And also it decomposes at higher temperature, understand? Hi guys, temperature at which thermal decomposition takes place increases down the group. This means that going down the group, the thermal stability increases also, yeah. That's it. Alright, guys. When you decompose a carbonate, right, you are only forming a single gas. Get me? Which means it's only carbon dioxide gas that you are getting. Clear? Alright, guys, I give you guys a question. At 400 degree, which carbonate release the most gas? Please let me know. Correct, the answer is MgCO3. Why? Because it's the least thermally stable. Hasana? Break it down, we are moving on. Sorry? Yeah, because it's the least stable, right? So it get broken down the most. Okay? Alright, guys, now let's continue. Please write it down. Thermal decomposition of nitrate. So guys, when you decompose a nitrate, right? Okay, so what do you get? You get a nitrogen oxide, okay, which is a nitrogen dioxide, which is formed as a brown gas. Wow, this is very important. This one very important, bro. So you get to see a brown gas, okay? Hey guys, now look at the reaction, right? The reaction, I call this as a 2-2-4 equation. Whenever I mention 2-2-4, this is the equation I'm talking about. So 2 times 2 equals to 4, or I just call it as 2-2-4. 2-2-4 equation. I mentioned 2-2-4. This is the reaction I'm referring to, because this equation is so popular, like very popular in your AS. Go and memorize your 2-2-4 equation. Okay, guys, go decompose your nitrate. Decompose your strontium. Practice writing, decompose your barium. Let's go. 1 minute. Alright, guys. Answer please. Turns into 2-2-4. Is that right? That's it. 1 to 11. Oh, your mock exam is only 1 to 11, Ethan. So which means you are quite close in completing a syllabus. I just need to know who I think some school might cover everything. If your school cover everything, you have to let me know, yeah. Alright guys, next, the thermal stability of nitrate also increases down the group. Remember, yeah, as you go down, thermal stability increases. Why? They're gonna decompose at higher temperature, yeah, please. That's it. Okay, so thermal stability increases, decompose at higher temperature. Yep. All good. Alright guys, now my study tips. Thermal decomposition of nitrate, right? Always form various gases. The moment you see the word various, we are talking about nitrate here. So what are the various gases we have? NO2, which is a brown gas, and O2, which is a colorless gas. So when you see brown gas, when you see various gas, we are talking about the decomposition of a nitrate. Okay. Good.